So we have to find out the cube root of the decimal number 19.683. Okay. So again, since this is a decimal number, we'll first convert this to a fraction. 19.683. We'll convert this to a decimal number by shifting the decimal. How many places? The decimal needs to be shifted 3 places. 1 place, 2 place, 3 places. Okay, so 3 places of decimal needs to be shifted. So this can be written as 19.683 divided by 1 and then followed by 3 zeros. Okay, so this has been converted to a fraction. Now the question arises here, which method should you use, prime factorization method or approximation method? Now you can use your prime factorization method, no problem, but since this is a 5-digit number, it is better to use approximation method. It's a big number. Okay, so what we'll do here is we'll find out the cube root of 19683 by approximation method. Let's use the approximation method. 19683. We group the numbers in threes. This is one group, and you add a 0. This becomes the other group. Okay, in groups of threes. Now, which cube number has the last digit 3? Which cube number has the last digit 3? 343 has the last digit 3, which is cube of 7. So therefore, we write our 7 here. Okay, and the next 3 digits now, if we see, is 19. 19 lies between which two cubes? 19 lies between which two cube numbers? If you see, 19 lies between 8 and 27. So 19 lies between 2 cube and 3 cube. So we take the lower of the two. We take the number 2, right? So therefore, we write 2 here. So therefore, what happens? This means 19683 is a cube of 27. Okay, that means the cube root of 19683 is simply 27. So therefore, what is the cube root of 19.683 is the cube root of 19683 divided by 1000. Now we have already found that 19683 is nothing but 27 cube. So we write 27 cube here. And 1000 is 10 cube. So this becomes cube root of 27 by 10 whole cube. So now we have a cube and we have a cube root. So I can remove the radical sign. It simply becomes 27 by 10, which is equal to 2.7. Okay. So this was another practice problem. We do the next one. Assignment problem that I had finished, no? I was doing uh, the exercise problems, isn't it?
Yes, sir.
And why didn't you tell me earlier? I forgot almost. Anyway, let us finish these two sums. I just remembered. We only had two sums left. So let's finish them. We had 6 2 left. Okay, the question here is find the cube root of 4 508. This mixed fraction is there. 1 3 3 1. You need to find out the cube root of this number. Now, what you do here is, first of all, you convert this mixed fraction to an improper fraction. And how do you convert this mixed fraction to an improper fraction? 1331 you multiply with 4 and you add 508, and all this is divided by 1331. Okay, we are converting this mixed fraction to an improper fraction. So this is 1331 into 4 is 5324 plus 508 divided by 1331. So this comes to 5 8 3 2 divided by 1331. Now the question here is, since you need to find out the cube root of this, you need to find out the cube root of 5832, and you need to find out the cube root of 1331. Now the cube root of 5832 you can find either by prime factorization or you can also use approximation. This time let us use prime factorization method because it is a 4-digit number. Let's use prime factorization. 5832. Okay, so this is what you are getting. So what are you getting here? These triplets you are getting. So you're getting a one triplet of, you're getting a one triplet of 2 and two triplets of 3. Okay. And what is 1331? 1331, you know, is 11 cube, right? 1331 can be prime factorized as only with 11. So therefore, what are you getting? Therefore, 4 508 divided by 1331 is 5832 divided by 1331, which is equal to, now we have prime factorized, so we'll just put the factors in the numerator. Okay, divided by, okay, so this is what you are getting. So here you are getting 2 cube into 3 cube into 3 cube divided by 11 cube. So this can now be written as 2 into 3 into 3 divided by 11 whole cube. So if you see, then this mixed fraction has been expressed as the cube of this fraction. Therefore, what should be the cube root? Cube root of 4 508 by 1331 is the cube root of 2 into 3 into 3 divided by 11 whole cube. Now we have a cube root and a cube inside. So we can remove the radical sign. We simply get 2 into 3 into 3 divided by 11. So this is 18 by 11. And so this should be your answer. Okay, any questions? Can all of you
No,
hear me?
sir. Yes, sir.
No doubt, sir.
Let us do the last sum of this exercise and finish it off. 6-3. The question here is find the cube root of 42.875. Okay. We first write this as a fraction because it is a decimal number. We write this as 42875 by 1000. Okay. Now we want to find in the numerator, we see that this is a 5-digit number. Okay, 1000 is already a perfect cube. 1000 is 10 cube. So now we want to find which number is the cube of 42875. Okay, so what you do here is you can use your prime factorization method as I did earlier, or you can use your approximation method. Since this is a 5-digit number, let us now use our approximation method. So this is 42875. Group them in threes. Okay. Now we have the last digit or the units digit 5 here. So which cube number has the units digit 5?
So
5. So 5 cube we see is 125, and this 125 has the units digit 5. This 5 has the units digit 5. So therefore we write a 5 here. Okay. And now we see the next group 042 or simply 42. 42 lies between which two cube numbers? If you see 42 lies between 27 and 64, right? 42 lies between, so which two cube numbers? It lies between 3 cube and 4 cube. If 42 lies between 3 cube and 4 cube, we choose the lower of the two numbers. Lower between which 3 and 4. So we choose 3 as our number. We write a 3 here. So therefore what you see here is 42875 is nothing but 35 cube. Okay. So therefore what is the cube root here? Cube root of this is 42875 is 35. Now coming back to the fraction, our given fraction, we had 42.875 42.875, which we wrote as 42875. Okay, now 42875, we found that this is the cube of 35. So I can replace this by 35 cube, and we know 1000 is 10 cube. So therefore, this can be written as 35 by 10 whole cube. Okay. So therefore, what should be the cube root of this? Cube root of this will be 42.875 is equal to the cube root of 35 by 10 whole cube, which is simply 35 by 10, because cube root of a perfect cube, 35 by 10, we can remove the radical. So therefore, now we get 3.5. The cube root of 42.875 is 3.5. So that is what this brings us up to an end of this chapter. Okay, and if you are doing the other sums, and if you have any doubts, you can ask later on also. In the beginning of each class, I always tell you, if you have any doubts, that is for any sum that I have left out that you will be doing for your practice. The minimum that you are expected to do is the sums that I am doing. Okay, let us now move on to the next chapter, which is your playing with numbers. Okay, yes, this I have sent you the notes last time. Now, in playing with numbers, we'll normally deal with algebraic expressions of representing numbers. Now, how do you represent a number in algebra? Let us say I give you a number like two-digit number 57. Now, this number has tens digit, okay, and it has a units digit. Okay, the tens digit here is 5, and the units digit here is 7. Okay, now this, the way we are writing this is, this number is actually made up of two digits. What are those digits? The two digits are 5 and 7. So 57 is made up of two digits, 5 and 7. Now this representation, if you want, if you are writing this number as 5 and 7 with the help of the two digits, this is called the usual representation of a number. Usual representation, the way we represent it normally, the usual representation. Okay. Now, in order to work with these numbers in algebra, what you do is you represent it in terms of its digits. Okay, 57 can also be written as, since 5 is the tens digit, so you can multiply 5 by 10 plus, and since 7 is the units digit, you can multiply 7 by 1. So this is the breakup of this number. 57 has been broken up into the these are all 10 and 1, these are all called the place values. Okay, so if I'm representing, if I have a number 57, this is called the tens place, and this is called the units place. Okay, so that is why I'm multiplying 5, the tens place digit, by 10, and 7 by the units place, the 7, which is the units place digit, by 1. Unit means 1. Okay, so this was about your two-digit number. This representation of the number, this representation of the number is called the generalized representation. Generalized representation. Now, in order to work with digits, we use the generalized representation. Okay, we cannot work with digits in the usual representation. We will not be able to work with digits in the usual representation. We will only work with digits in generalized representation. Okay, so suppose now if I give you a number xy, and obviously here it does not mean x into y. Okay, this is not x into y. Okay, xy. Suppose any number if I give you xy. Okay, then can you tell me if this is your usual representation, then what should be the generalized representation? What should be the generalized representation of this number? Can anyone tell me what should be a generalized representation?
Sir,
Yes, yes.
x multiplied to 10 plus y multiplied to 1.
And why is it so? Why is it so? You are right, but why is it so? It is because if you see, compare xy with 57. Okay, so this is your tens place,
Yes, sir.
and this is
Answer
your
1.
units place. Okay, so tens place digit is x, so we multiply x with 10. Okay, and give a plus sign, and the units place digit is y, so you multiply it with 1. So your generalized representation of this number is 10x plus y.
10x plus 10.
Now suppose if I reverse the digits, instead of xy, if I give you this number yx, and I say this is the generalized, this is the usual representation. I say this is the usual representation. Okay, then what should be the generalized representation of this? What should be the generalized representation of the number yx? If you see, this is your tens place. This is your units place. So because y is in the tens place, y has to be multiplied by 10. And since x is in, this x here is in the units place, so multiply it with 1. So this is 10y plus x. So I took the number xy, okay, and I got the generalized representation as 10x plus y. Okay, now what I did was I reversed the digits of the number. From xy, I made it yx. The generalized representation changed to 10y plus x. Why is this happening? Let us come back to this example, 57. 57 is the usual representation. Its generalized representation is 5 into 10 plus 7 into 1. Now suppose if I change the order of the digits. If I change the order of the digits, what does it become? 7 becomes the tens place, 5 becomes the units place. So this is my usual representation. So what should be my generalized representation? What should be my generalized representation? 7 here is in the tens place. So I multiply 7 with 10. And 5 here is in the units place. So I multiply 5 with 1. So now you see the difference. 57, if I took the number 57 in the usual representation, my generalized representation was 5 into 10 plus 7. Now what I do is 57, I reverse the order of the digits. From 57, I make it 75. That is, I'm interchanging the digits. 7 from the units digit, say I'm making it, I'm taking it to the tens place, and 5 from the tens place I'm taking it to the units place. Then the generalized representation of the number changes to 7 into 10 plus 1. Okay, any questions till this part?
No, sir.
No, sir.
Now suppose if I take
No, sir.
an 3-digit number, say I take a number 673. Okay, I take the number 673. This is clearly a 3-digit number, and this representation is the usual representation. Okay, now in a 3-digit number, what you must see is that this is your hundreds place, this is your tens place, and this is your units place. So how will I represent 673 in the generalized representation? The generalized representation of 673. First, if you see 6, the digit 6 is in the hundreds place. So you multiply 6 by 100. Then you give a plus sign. 7 is in the tens place. So you multiply 7 with 10. 3 is in the units place. So 3 you multiply with 1. This gives us our generalized representation of 673. Now in a 3-digit number, can you tell me how many other digits can you make if you change the place order of the digits cyclically? You know what cyclically means? 673, 6, 7, and 3. This is a cyclic order. Okay. Now we are starting with 6. So the next digit comes as 7 and 3. Now if I start with 7, what number can I make? The next digit that comes is 3, and the next digit comes is 6. So what I have done is I have changed the order of the digits. Same number, 673. From this I get a different number. Okay, what number am I getting? I'm getting 736. How am I getting? I'm changing the order of the digits cyclically. Changing the order of 673 cyclically. This is one number that I get. Okay, and this one is my usual representation. This is my usual representation. And what should be my generalized representation of this? Generalized representation. Generalized representation should be 7 is in the hundreds place. So 7 needs to be multiplied by 100. Then a plus sign. 3 is in the tens place. So 3 has to be multiplied by 10. Again a plus sign. And 6 is in the units place. So 6 has to be multiplied by 1. So this is my generalized representation of 736, which I obtained from 673 only. Now there is another number that I can obtain from 673 if I change the order of the digits cyclically. What is that number? See, I gave you the number 673. The next number that I started was from 7. This time I start from 3. So what is the next number that I'm getting? 3 if I start
3,
from
6.
6 and 7. Okay. Changing the order of the digits. Changing the order of 673 cyclically. Okay. Sampurna Biswas, has she joined? Hasn't joined. Okay, changing the order of 673 cyclically, we get another digit 367. So this is my usual representation. And my generalized representation is 3 is in the hundreds place. So we multiply 3 with 100 plus 6 in the tens place and 7 is in the units place. So this is my generalized representation. So what do we see? By changing the order of the digits cyclically, not any order, cyclically, by changing the order of the digits cyclically, we are getting three numbers from 673. What are those numbers? We are getting 736 and we are getting 367. Okay, not any order. We cannot write this as 36. We cannot write this as 763, because in that case 763, although all the digits are there, but this is not in cyclic order. Is 763 in cyclic order? No, because after 7 comes 3, isn't it? So this is not in cyclic order. So if we are interchanging the uh, order of the digits cyclically, then we'll only get two numbers from 673. This number and this number from 673. We'll do a problem based on this concept little later. Okay. So this, I stop here for today.